Good afternoon, everyone. My name is Molly O'Brien. I'm a PhD candidate in the Department of Computer Science at Johns Hopkins University, and today I'll be presenting my work, Network Generalization Prediction for Safety-Critical Tasks in Novel Operating Domains. The key results of our paper are as follows. First, we outline the task, Network Generalization Prediction, which is predicting the expected neural network performance in a novel operating domain. This is essential when neural networks are performing safety-critical tasks in unconstrained environments. For example, performing perception for self-driving vehicles. We perform network generalization prediction using a novel context subspace, which is a low-dimensional space encoding the interpretable context features that provide the most information about the network performance. We demonstrate our network generalization prediction algorithm on pedestrian detection and demonstrate that we can accurately predict pedestrian detection recall in various operating domains. To perform network generalization prediction, we start by defining the context subspace using a subset of the context features, where the context features are attributes that are available that describe the input data and the data environment. For pedestrian detection, context features of interest could be the time of day in the image, or the weather. We define the context subspace using the context features that provide the most information about the network loss, and we measure that information using the mutual information. If we consider multiple context features to describe the context subspace, we subtract the mutual information between the context features to define the context subspace that's informative about the loss and that does not have redundant information. We predict the network performance by weighting the expected loss for a context in the context subspace by the likelihood of encountering that context in the novel operating domain. We evaluate our network generalization prediction algorithm to predict the pedestrian detection recall. We test using a subset of the Berkeley Deep Drive dataset and define the context subspace that's most informative about performance as the image brightness, whether the pedestrian is safety critical or in the drivable area, and the scene type, which is the highway, residential, or city street. First, we evaluate our network generalization prediction algorithm on 8 novel operating domains that are defined by specifically sampling held out data from the BDD dataset. And we define these novel operating domains as either in the daytime or in the nighttime, with small groups of pedestrians or large groups of pedestrians, where we define large groups as greater than or equal to 5 pedestrians, and also whether the pedestrians are not safety critical or safety critical. And here you can see the blue boxes are showing not safety critical pedestrians, which are, for example, on the sidewalks, where the safety critical pedestrians are, crossing the street, they're in that drivable area. Here we show our network generalization prediction results, where in the dark blue and the dark red are the observed pedestrian recall, and in the light blue and the light red are our recall predictions. You can see that across these different operating domains, we make accurate network generalization predictions that are accurate to within 2% for not safety critical pedestrians and within 5% for the safety critical pedestrians. The one exception is for nighttime large groups of safety critical pedestrians. There was only one image that fell into this category, so the observed performance is based off of a small amount of data. We also investigate whether our context subspace is informative for completely unseen datasets, and we find that the context subspace does allow us to make predictions for pedestrian recall, but these predictions have a bias, and we believe this is due to factors that change between the datasets that our context features are not able to capture. In conclusion, we identify interpretable context features that are informative about the network performance. We're able to make accurate network generalization predictions for novel operating domains within a fixed physical setup or a given data set, but in the future, we'd like to investigate how to improve our predictions for novel data sets. We'd like to thank Exida LLC for their generous funding of this project. Here are the references to the data sets we use. And thank you all for your attention.